Alright, what we're going to take a look at is what we call the distributive property. Distribute, just like this man distributes papers. What the distributive property does is it is an algebraic property which allows us to use multiplication in a single term or with multiple terms inside of parentheses. It's also known as scalar multiplication. So you're scaling something, you're increasing it by a scale. Now what we're used to seeing is we work with what's inside of the parentheses first, which gives me a 9. Then I can multiply 2 times 9, get my final answer of 18. What the distributive property tells us is what we can do is we can distribute this 2 to the 3 and the 6 first. So we will have 2 times 3 plus 2 times 6. Then we can add them together and we'll get 18. Now I know you're looking at it from the left hand side to the right hand side. You're saying we added a step. That's not necessarily what we want to do. I agree. The less work the better. But sometimes we can't simplify. We can't solve whatever is inside of those parentheses. So it tells us we can remove the parentheses and we can start to work with the terms and we can try and simplify those terms and solve equations eventually. What you'll see here is we've got 6 times what's in parentheses is 2 plus 4x. Right? In parentheses we cannot simplify that anymore. 2 plus 4x, they are not like terms, so we cannot simplify them. 2 is a constant, 4x has a variable, we can't combine them. So what we can do is we can distribute. To distribute, we take this 6 and we distribute it to both terms. When you're distributing, you're multiplying. So we have 6 times 2 gives me 12. 6 times 4x, all we're going to do is multiply the constants together. Gives me a 24x. Right, now I still cannot simplify that anymore because I cannot combine unlike terms. But it does look a little prettier than this ugly 6 times 2 plus 4x. Now we're trying to make it look better. That way in the long run, it's going to help us to do what we want to do. And what we want to do will be to solve equations. Now if we look in here, we've got 8 times 7 minus x. Inside of the parentheses, we cannot do any more simplification. Without distribution, well, there is one way we can solve it, but I think distribution will be the simplest way. I'll show you that second way in a minute here. But if we want to distribute, we're going to take this 8 and we'll distribute it to both of our parts here. So we'll do 8 times 7 gives me a 56. 8 times negative x gives me a negative 8x. We didn't do anything to that right hand side, so it's just going to hang tight. We still have 70. Now we just have a two-step equation that we can solve. What you can see is with the variable, the first thing we're going to do is multiply it by negative 8. Then we're going to combine it with positive 56. Since we are combining it with that positive 56 second or last, that's the first thing I want to get rid of. First thing I want to get rid of is this positive 56. To get rid of that, just a negative 56. 0, these two cancel out. I can bring down my negative 8x. On the right hand side, I've got to do that same exact thing here. If I subtract those two, 70 minus 56 gives me 14. So now I'm left with negative 8x equals 14. To solve this one, we have a one-step equation. We've got to get rid of that multiplication of negative 8. To get rid of that, cancel it out. We're just going to divide by negative 8. If I divide this by negative 8, those two are going to be a 1. I will be left with just x on the left-hand side. On the right-hand side, then, I've got to do that same exact thing. 14 divided by negative 8. It doesn't come out even. So we'll just reduce it down to negative 7 over 4, which we could also call negative 1 and a quarter. So really all that distribution does is it allows us to get in there, since we can't combine those like terms, inside of parentheses, at least we can break them up a little bit and we can solve this two-step equation. Now looking back at it, I said there's a way we can do it without distribution, and there certainly is. We can look at this entire problem as 8 times 7 minus x. So the last thing we're going to do if we look at the variable, first thing we want to do will be to combine a negative x with a 7 here. The last thing then would be to multiply that whole thing by 8. So if I want to go backwards and I want to get x alone, all I've got to do is get rid of that 8. To get rid of that 8, I can look at it and I can say, alright, I'm going to divide this side by 8. That's going to cancel those out. Whatever I do to the left-hand side, I have to do the right-hand side as well. So I have 7 minus x is equal to 70 over 8. So we're jumping into the fractions right away. Not a bad thing, but it does make the problem a little bit more complicated. Alright, next step, we want to get rid of that 7. So we'll subtract 7 on each side. These two are going to cancel out, leaving me with negative x. Make sure that you write negative x. That's very important. Now I've got 70 over 8 minus 7. Well, what do we got to do there? We got to go in and we've got to find a common denominator. If I use 8 as my common denominator, I'm going to rewrite this 7 as 56 over 8, which leaves me with negative x is equal to 70 minus 56. Oh, that gives me a positive 14 over 8. Right? Now, if you recall, the answer was negative 14 over 8. Last thing we have to do here is get rid of this negative in front of our variable here. Now remember, that's a negative 1. I'll just divide both sides by a negative 1. That's going to flip the sign for me, and it's going to give me that x is equal to negative 14 over 8. So really I can solve the equation both ways. I personally think it's easier to use the distribution first and then go about solving the equation.